Khan Academy volume, and we're working on the subtopic, decompose figures to find volume with unit cubes. Okay, so they're reminding us, we're going back to the cubes now. So they're reminding us one unit cube looks like this, and what is the volume of the following figure? So here's our front view, okay, and then they're just reminding us of what the back view looks like. So in this one, okay, things are a little bit different because we're missing those two top green squares. So we can't strictly do our volume equals length times width times height because the height on this side is different than the height on this side. So you can do this a couple different ways. With this one, you might be able to just actually count the cubes and be okay with doing that. If you are not able to count the cubes, if that's not making sense, then what we want to do is we want to kind of ignore the green cubes at first and just focus on the blue and the red. So if I just focus on the blue and the red cubes, because those ones are creating a perfect array, a perfect rectangle, then I can still use my volume equals length times width times height. And if I'm just looking at the blue and the red, my length is 1, 2, 3, 4, 5. My width is 1. And my height, if I'm just looking at the blue and the red, my height is 2. So the volume of just the red and the blue is 5 times 1, which is 5, times 2, which is 10. And then I can see that there's 3 green cubes on top, so that's 13. Now, if you're looking at this and you're saying, hey, I don't need to do this, I can just count these cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Great, definitely do it that way. You've got to find what works for you. For some people, it's really tricky, to see this as a 3D shape. And then sometimes fifth graders want to count both of these squares right here, and we got to be careful about that. Remember that in this case, this is our front view of the square of the cube, and this is our side view, so it only counts as one cube. Okay, so again, they're just showing us so that we can get a full view of what we're talking about here. Okay, in this case, again, I'm going to decompose, which means I'm going to break apart. So I'm going to kind of ignore this, this pink and green part for now. Just ignore that, okay, and just focusing on the blue and the red. So volume equals length times the width times the height. And my length of just the blue and the red is 2. My width is 1, 2, 3, 4. And my height, if I'm just looking at the blue and the red, is 2. So my volume of just the blue and the red is 2 times 4, which is 8, and then times 2, so 16. And then if I go back now and look at my pink and my green, I can see that I would have 16. I can see this is 17, 18, 19, and 20. What is the volume of the following figure? Okay, again, I can see that the green is kind of its own separate little section. It doesn't cover everything here. So I'm going to go right back and I'm going to work on that volume equals length times width times the height. And I'm just going to focus on the blue and the red because those ones do make a full rectangular prism. So the length is 1, 2, 3, 4, 5, 6, 7. And my width, it goes back 2, 1, 2. And my height is also, and my height is also 2. So 7 times 2 is 14, and then times that again would be 28. So just the blue and the red is 28. And then I can see my green cubes up here. So 29, 30, 31, 32, and then I have another row of 4. 33, 34, 35, 36. Okay, and again, I'm going to just stick with that volume equals length times width times height. That got to be a little bit of a crazy W. Thanks for your patience with that. Length. Okay, so I'm getting rid of my green and my pink again. Okay, I'm looking at just my full rectangular prism down here. So length is 1, 2, 3, 4, 5. My width, ooh, baby, 5. My width is 1, and my height is 2. So the volume of just my blue and my red is 5 times 1, which is 5, times 2 is 10, and then I can add on my green and pink cubes. 1, 2, 3, 4 of them. Oops, I gotta add that. 14.